All right, and finally in chapter 4, 4.7, we want to do the inverse trig functions. So we already know that if we have an angle, we can apply a trig function to it and get a number back. If we have a number, we should be able to apply an inverse trig function to it and get an angle back. So again, the trig function takes us from an angle to a value. The inverse trig function will take us from a value back to an angle. So whenever you the notation sine inverse of x, this is not 1 over the sine of x, this is the inverse sine. And because too many people have made the mistake that this should be 1 over the sine because of negative exponents, we also very often, instead of saying the inverse sine function, we'll call it the arc sine or the arc cosine. So when you hear arc, you should just think inverse. All right. And so remember, with the inverse trig functions or the arc functions, we should be getting angles back. Now, in order for our function to quote unquote make sense, we want to make sure that we have a one-to-one function. So if I look at a full period of my cosine function, that obviously is not one-to-one because it fails the horizontal line test. If I want a full picture of the cosine function, I would just take this first piece and then I'd have to quit in order for it to be one-to-one. So only the first pi units of the cosine function are going to be used if I'm talking about trying to restrict my domain to make a one-to-one function. Similarly with the sine function, if I used my first pi of a basic period, I would not be one-to-one. And so usually for the sine graph, we're going to use the interval from minus pi over 2 to plus pi over 2 to get one piece where we don't violate the horizontal line test. All right, so the important thing to remember out of this then is that when we take the arcsine function or the arctangent function or the arccosecant function, for any of this, when they exist, we're going to have to be careful to make sure that we pick angles for the inverse trig function that's in the correct place. Anything that's based off of the sine function, I think of the sine, and obviously the cosecant is 1 over the sine, so those are both based on the sine function. And my stupid memory trick is I think of the arctangent as also being based off of the sine function because arctangent is sine over cosine, so sine comes first. All right, both of those are going to give me a range or angles back that are going to be between minus pi over 2 and plus pi over 2. Again, whether I include or exclude the endpoints is going to depend on whether the function makes sense there or not. But those are going to be quadrants 1 and 4. So minus pi over 2 to plus pi over 2 are the angles I can use for those. For the arc cosine, again, all the ones built off of cosine. So our cosine, our cotangent, right? Cotangent is cosine over sine. And the arcsecant, which is 1 over sine. Those are all going to give me back angles between 0 and pi, or in quadrants 1 or 2. Again, what we're really worried about is when we take the inverse trig function of a negative number. Because if it's a positive number, we're going to end up in quadrant 1 no matter what trig function we're dealing with. But if it's a negative number, then I have to worry about, am I looking at values in quadrant 2 or in quadrant 4? And that's where I'm going to have to be careful. Okay? So we can play the same game. If we're talking about the arcsine of x, we want to recognize that if I have the sine of x and I apply the arcsine to that, I should just get the angle back. Similarly, if I want to get rid of an arcsine, I should take the sine of it and get the sine of the arcsine of x should also be x. Okay. All right. So I'm not going to care much about most of the graphs because we don't use them that often. But we should know that the arcsine graph is going to have a domain of minus 1 to 1 and a range from minus pi over 2 to plus pi over 2. And it's going to start at, wow. When it's at -1, it should be at minus pi over 2, so I'm going to have to start over yet again. But this should actually go up as it goes from left to right. So apparently I'm not even going to care very much about that one because I couldn't get it right. I'm not sure how I screwed that up because that's a really basic error. But truthfully, I don't draw that graph very often either. So I guess I'm not terribly surprised that doesn't look right. The arctangent is the one I actually care about. And the reason I care about the arctangent is because the arctangent shows up in a lot of places as an actual function. And the reason it shows up that way is because it has a steady state process. In other words, as you go to infinity, you get a horizontal asymptote. So on the right-hand side for the arctangent, you're going to go to plus pi over 2. If you're looking at what happens as you go left on the arctangent function, it's going to have a value, horizontal asymptote of y equals minus pi over 2 over 2. Okay, but it's going to be really important that we recognize that the inverse trig functions give us back an angle. All right. So again, anything based off of the sine function will give us an angle back that's in quadrant 1 or 4. Anything that's based off of a cosine function is going to put us in quadrants 1 and 2. And we're only going to care if the value that we're using is negative. So if we look at the arc cosine of -1/2, I'm looking at the 1/2 and I'm saying, gee, the reference angle for that is going to be pi over 3. That I know. Because if nothing else, I drew my table, and my table shows me that if I've got a 1/2, it should go with pi over 3 when it's a cosine. So that means I'm looking at an angle for the cosine to be -1/2, should be in quadrant 2 or 4. Which of those do I want? Since it's a cosine, I want quadrant 2. So a reference angle of pi over 3 in quadrant 2 is going to be 2 pi over 3. And so the arc cosine of -1/2 should be 2 pi over 3. Arctangent of -3, well, the arctangent is based on a sine, so this is actually really easy. We get the reference angle, which is pi over 3. We know that since my choices are quadrants 2 or 4, I'm going to pick quadrant 4. And more importantly, because I'm in quadrant 4 with reference angle of pi over 3, I could call it 5 pi over 3, but that's not the right domain, not the right range for the arctangent. I need minus pi over 3. Similarly, for the arcsine of -√2 over 2, I know my reference angle is pi over 4. Sines should be in quadrant 4, not quadrant 2 for me. And so for the arcsine, I'm looking at a negative pi over 4 value. Okay, so the ones that are based on the sine function, the arcsine, the arctangent, and the arccosecant, those are going to be my easy ones because all I have to do is get the reference angle and put a minus with it. If I'm looking at something based off of the cosine and I have a negative input, then I have to be in quadrant 2, which basically means I'm looking at pi minus my reference angle for my output. Okay. All right. So this actually works because the arcsine, the arctangent, and the arccosecant are both odd functions. We can't say that the arccosine, etc., are even functions because they really aren't. The arccosine isn't even identified for negative values, so we can't talk about symmetry across the y-axis in this case. All right, I think we'll break there and we'll come back and do the other part as a separate recording.